Hey guys, so the video that you're about to watch is part one of my series on ARM assembly. So basically every few days I will be posting a new tutorial that adds on to that series until I'm done, of course. So this is part one. I didn't actually get the chance to make a proper ending to this video, so that's why I had to just cut it off and just tell you in advance that this is part one and part two will be coming shortly, because the way I just ended off this first video, it sounds like it's incomplete. Don't worry, more videos will be coming in the near future, and with that, enjoy this first video. If you clicked on this video, then you probably are also struggling with learning ARM assembly. When I first started learning it, I had absolutely no clue where to start. I had no good resources, no good mentors, and I was just lost upon starting my class on machine organization and ARM assembly. So if you're on the same boat as me, then this video is for you. I promise after watching this video, you will no longer say that there are no good resources out there, nor good mentors. And don't worry, if you have absolutely no background in programming, I will walk you through every step of the way, and I will show you exactly what it means to be an ARM assembly programmer, what ARM is, what assembly is, and what programming is, if you will. Alright, so without further ado, let's get into it. Alright, so first things first, we need to understand what exactly ARM assembly is, because this is a tutorial for beginners. And so I have this image here. Shout out to Free Code Camp for presenting this image. I actually don't know the original source of the image, but I found it on a Free Code Camp video. Conveniently, it was from a video when I was trying to learn ARM assembly. No offense to that guy who made that tutorial. It's a great tutorial. It's just I don't think it was as beginner friendly as this tutorial that I'm making for you guys. So, but the image that they provided at the beginning of that tutorial is still I think it's a very useful depiction of understanding the fundamentals of a computer and thus where assembly comes into play. So, you might not be a computer scientist or a computer engineer, but you don't need to be to understand this. So, at the bottom of this picture right here, so if I go to our thing, so here we have hardware, which is just all the electronics, logic gates, circuits, all of that. I'm actually not a computer engineer, so I couldn't tell you much about that myself, but that's exactly that's the most fundamental. Like, we got silicon and all of that. See, this is a tutorial coming from someone who's not an expert on like every single one of these layers, but I can, at the very minimum, tell you how to code in a way that's very beginner friendly. So I guess this is more of a beginner to beginner tutorial than an expert to beginner tutorial. But I still think that I just think there's a lot of missing pieces of a tutorial, especially an assembly tutorial, that comes when teaching complex stuff like this, because when we first learn how to code, we usually start at the high level languages here, like Java, C++, you might be familiar with, but none of that knowledge essentially prepares you all that much, or doesn't prepare you well enough for learning the level underneath, which is the assembly language. So I want to take things down to the very bottom in order to understand where you are on the spectrum when you say you want to learn assembly. So we got the hardware there, and then we got the machine language, and the machine language, or the machine instructions, are the set of ones and zeros. So or binary is the more accurate term. So I'm sure you might have heard of this before, but all a computer understands are ones and zeros. However, what people probably failed to tell you is that the ones and zeros, those digits themselves, are not what a computer understands. Ones and zeros are just a human representation of what the computer actually understands, which is high level voltage, or high voltage and low voltage, the one being high voltage and the zero being low voltage. So that's all a computer understands at the fundamental level. But obviously, it's very tedious for us humans to program stuff like that, especially write complex programs like that. And that is where the assembly language came. It's before all the high level languages came. So the assembly language is there because it's just a matter of evolution of human history and trying to use programming languages or trying to use languages to make programming as efficient as possible. And now this is, I guess, an outdated visualization because now we should have one layer above this, which is natural language. Because now with AI and everything, traditional programming is kind of becoming obsolete. But anyway, so machine language is all a computer understands. And in order to get to that phase, instead of having to type in ones and zeros, smart people, they invented what's called the assembly language. And this isn't one programming language, as you see Java or C++. This isn't a single programming language. There's different variations. So these different variations, they come from different instruction set architectures of the computer's processors. So, or they work specifically, sorry, that's slightly bad terminology. They worked for a particular processor architecture. So, the Intel x86, that's one processor architecture, and that there is an assembly language for that. And there's another processor architecture, the new MacBooks are using it. It's called the ARM architecture, and that is another assembly language, and that's what we're going to be focusing on because that is the most popular one. And although technically it's not very practical to use assembly in the modern industry, ARM assembly is still useful to learn because it's what goes on in the modern processors, if you will. So that's where we got assembly. But of course, assembly itself is too tedious to write, so the concept of high-level languages came later, and the first high-level language made was actually C. And I don't want to distract you guys from the topic of this video too much, but after C came more programming languages like C++, then Java, and then Python, which is the most popular one. And then after that, we got visual languages like HTML and CSS for web development. And then, like I mentioned earlier, we have a layer above for natural language. So that's basically the fundamentals of a computer taught by an absolute amateur, but someone with enough expertise to tell you what exactly assembly is on the spectrum of computer architecture. So, once again, like I said, I'm not completely an expert on every single one of these layers, which is why if you would like to go to a video where someone's who's an expert in hardware, or machine language, or and any one of these, then, feel free. There's no stopping you. But the purpose of this video is not to teach you like an expert, but to teach you from the perspective of someone who also struggled to learn assembly because every person that the tutorials were taught by were, taught by an expert, and thus it was very difficult to follow along as someone who only had a background in the high-level languages, which I'm assuming is most of you that clicked on this video. So this is just me trying to be as relatable as possible while still presenting the knowledge I know and the knowledge that you wish to obtain. So yeah, so that's basically how this tutorial is going to go. And if you're up for it, then feel free to continue, and we are going to get started right now. Now let's talk about what you need. So I am going to go on a limb here and assume that you want to learn assembly because you are in a class on computer architecture slash machine organization slash assembly, ARM in this case. Well, if you, again, this is just speaking from my experience with a machine organization class, but you are going to need a Raspberry Pi. So the Raspberry Pi is any model really should work. Like anything 2, 3, or even 4 should work. I'm using the Raspberry Pi 3 in this tutorial. Yeah, that's basically the base for this video. Like this whole tutorial is centered around how to and there are going to be some Raspberry Pi specific things. That's what I mean. There are any things like the Y Raspberry Pi, because they have things like the GCC compiler, and of course it has the ARM processor, unlike my PC, which has the Intel processor. And I could use an emulator or a virtual machine, but I already have the Pi set up, so if you would like to use an emulator or a virtual machine, then feel free. Otherwise, if you have a Raspberry Pi, go ahead and use it. I think that will definitely be the most effective when following this tutorial. So go ahead, get out your Pi, and if you need help setting it up, I have a tutorial linked in the description, because I don't want to divert, as much as I don't like sending people to links just to get all the information, as much as I like putting everything into one video, I don't want to divert people from the purpose of the video too much, so it is still learning ARM assembly, so I don't want to waste time thinking about making a sub-tutorial, if you will, on how to set up the Raspberry Pi. So there's a tutorial linked in the description, and if you have that set up, or if you have your virtual machine or emulator loaded, I have the link to an emulator in the description. And then I'm not very familiar with virtual machines, but I will also have a link in the description for that one once I look into that after recording this video. So once you have your tool set up, the next thing you're going to need is an IDE. So I'm going to be using a VS Code, since how I'm doing this is I am on the Raspberry Pi, which has a Linux operating system. So make sure when you're following that tutorial on how to set up the Raspberry Pi, make sure it's set up with the Linux operating system. And then I used an extension on my PC, on Visual Studio Code on my PC, called SSH. And with that, as well as copying all the IP addresses and everything, and all that fancy stuff, I am able to work on my PC to write the code for ARM assembly. So, which is for anything that's on my Pi, all the storage, all the files, everything that's on my Pi, I am working remotely on my PC. So I will leave another link in the description below on remote SSH and how you can use that to remotely work on another device, aka your PC, from the device that actually has the necessary components like the Raspberry Pi. So at this point, I'm assuming that you already have your code editor or virtual machine or whatever set up, and you are ready to get coding. So once again, I am using the Raspberry Pi, and but I'm using SSH to be able to connect this to my PC so that I can more efficiently record this video. And basically, there are some hidden stuff. I didn't record the full screen for this part of the tutorial, just because there are some private stuff on the top and left. So if you don't see, I will tell you if I need to go to a part, if I need to click file or something, which is not available or which is not visible in this window that I'm displaying to you guys. I will tell you to go to the top left corner and click file or whatever. So I'm If you are using the Raspberry Pi, just make sure you have a folder and file all set up. I just created a tutorial folder separately, and that's what I'll be using. So, on the left side where your folder is, the folder you have open, you are, again, this is specific to people using an IDE, and yeah, well, if you're using an emulator, then you can ignore all of this. So, we're going to hit new file, and then I'm going to call it, let's call it, okay, we're just, yeah, we're going to say main.s because what we're using, at least on the Raspberry Pi, we're using a compiler called GCC compiler. Now, I am not going to go into the details of that, but it is a compiler that basically functions for ARM assembly and for the high-level language C. We're not going to get into C in this video. We're strictly sticking to ARM assembly. So that's that. But the GCC compiler still has a lot of commands that I'm familiar with, so it'll just be easier for me to do this tutorial or from me using the Pi. So and as a result of that, the function or the file we have to call this is main.s. We don't have to call it main.s, but I prefer to stick with the convention. But the function will have to be named main.s. So what we are going to do here is, this is specific to the Raspberry Pi, once again. The first thing we have to do is we have to set up information for our, like regarding the processor information for our Pi, so that we can apply it to this program, so that the program compiles and runs, basically. So I will post in the description the specific processor information for the different models of Raspberry Pi. But for now, I already have the information for the Raspberry Pi 3 with me in a separate window. So what I'm going to do, let me just quickly pull that up. I have it somewhere here. Okay, let's go ahead and yeah, okay, let's just cut to this when this is pasted. Alright, so for the Raspberry Pi 3, this is the standard information that you want to put in your at the top of your main.s file. If you have a different model of a Raspberry Pi, then these first two lines will be different for you. In that case, you're going to want to look at the description, what I provided. Okay, so once we have this, if you don't know what this stuff means, don't worry about it. We're not gonna get into the nitty-gritty of that. All you have to know is that this is just standard information if you're using the Raspberry Pi. Now, if you're using an emulator, then you might have like a .global here, and you might have a start. For you guys, it's start since it's different. If you're using the particular emulator that I provided, with that, you basically are already set up because all the standard lines are already provided to you. But other than that, just know that all the start, like anything underneath start on that emulator, is underneath main on in this, what I'm using. So, I'm going to show you some basic commands. So, the first thing we need to understand is what is a register. And by the way, to add comments, we are just going to use the @ sign. So, what is a register? A register, what you have to know about is that a register is what allows you to add, store, load, and move values, like numerical values. And if depending on the context of what you want to do with your assembler program, you can basically use registers to work with the memory or the RAM. If you're familiar with PC specs, working with registers, you can basically you can use things stored in the RAM for short-term use. Now, if you still don't know what I'm talking about, don't worry. I will show you exactly what this means code-wise. So we have these different registers here which are numbered, and you might see them on the left side of your emulator. So we got these register numbers. So we got R0, we got R1, and we got R2, and so forth. And there are some special, like most of these registers, for our purposes, we can use anywhere, anytime. R0, we'd have to be careful. I'm going to show you why in a second. And there are some special purpose registers, like I think R11, R13. Then again, we don't really have to worry about that for now. So that's for later. Right now we're going basic. I will get a little more advanced later in this tutorial. But for now, all you need to know is the concept of registers. So what we're going to do here is our very basic program here. We are going to say, let's move the value, let's pick a number, let's go 5, into register 0. All right? So the move command, you can use all caps for this or you can use all lowercase for this. It doesn't matter. I have just been using all lowercase, so that's what I'm going to use. We're going to say MOV. That's move. That's the move command in assembly. Now, how exactly we want this, let me add another comment here. When we're using the move command, we want move, and I'm going to use variables for this, so go ahead and I'll explain to you what this is. Move x comma y. Now, what does this mean? So, x is basically it's the place where you want to move the value into. So, move value into x is that's the placeholder. So register is not exactly a memory per se, but it allows you to work with memory because you can store values into it, you can move values into it, and like that. And then what's y? Y is what holds the value. So y is the value that we want to move into x. So the value we want to move into x. So in our case, like I said, we want to move the value 5 into register 0. So what we're going to do here, remember, we move whatever value we want to move into x. So x has to be register 0, or R0. And then what's y? Y is the value we want to move into x, and we want to move the value 5. So in assembly, how you want to move integers is you're going to use the hash symbol, and then you are going to put the integer, which is 5 in our case. And that's it. That is what a move instruction does. So as promised, the next thing we are going to work on is the modulo. So what is modulo? Modulo is just when you take the modulo of two numbers, it gives you the remainder after dividing them. So unlike udiv, which gives you the quotient, or the whole number quotient, the the remaining decimal part is, or not your remaining decimal part, okay, sorry, bad choice of words. udiv gives you the largest whole number that fits into, okay, scratch that. Unlike udiv, which gives you only the whole number when you divide two numbers, modulo gives you the remainder. So in this case, 18 modulo 5, if you just divided them with udiv, you would get 3. Actually, this is a bad case. Let's use 19. If you just divided them, you'd get 3, and it wouldn't account for the remainder of 4. I changed from 18 to 19 because both the whole number and the remainder are 3, and I didn't want to confuse you guys. So the remainder would be 4, and that's the goal of modulo. It would return that value of 4 instead of 3, and which is what udiv would give you. So how we do mod is, let's say we wanted to take, so we're going to use this example. So the first thing is we need to start by taking the division. So we're going to first do a udiv. Actually, no, before that, we need to actually get these values. So move into register 0. Hopefully you guys are familiar with this now. 19, and then in register 1, 5. And now we can do the mod operation. So the first thing we have to do is we have to do a udiv, and then let's put the result into R2. So R0, R1. So in register 2, we get the division result from between 19 and 5. So just to make it clear, by adding a comment, in R2, we get 3. Now the next step we have to do is we need to, it'll be easier if I write the comments first. So the next thing we have to do is we need to multiply that result, so the quotient, by the divisor. Now why is that? Because when we divide, we get a whole number and it ignores the remainder. So if we multiply by the divisor, we see how much, it's like a progress bar. You have your 19 and we get 3 from the division. So if we multiply 3 times 5, we see that we get 15, which is how, we get 15, which is how far groups of 5 can go into, if that makes sense. Because if you add another 5, you get 20, which exceeds 19. So next thing we have to do is we have to multiply. If you're confused by what you just said, don't worry. It'll make sense once we write these lines. So the next thing we have to do is multiply. And we don't really care about the 3 in this case because we're just using it. So we can put this value into register 0 and we'll update it. Now, we want to multiply that value. So in the value in register 2, which is 3, we want to multiply the value R1, which is our divisor, 5. So 3 times 5 is 15. Now that gets stored into register 0. That overwrites the value 3. So this is something important to keep in mind. If you're using the same registers in multiple times in your program, do beware that they can get overwritten if you aren't careful. But if that's what you intend, which is what I'm intending in this case, that register 2 gets overwritten with 15, then you use it accordingly. So now that we have 15 stored in register 0, the next thing will be we need to take that product and we need to subtract it from the dividend, which is 19. So take that product and subtract from dividend 19. or if we're keeping it dynamic, in register 0. Actually, no, we're sticking with the example. Okay, so 19 is the same thing. Then, so if we're taking that product and we're subtracting, so naturally what should come to mind is using the sub command. And then, again, we're going to keep overriding register 2 because we keep using those values and then, then we no longer need them. Unlike our values in register 0 and 1, we need to keep them because those are the actual numbers that we want to get the modulo of. So in register 2, we are going to do, we have the product stored in register 2, so we want to subtract that. So let's start with what's in the dividend, or what the dividend is held in, which is R0, 19. And then we want to subtract the product that we put in R2 in line 20 from the dividend. So we just put R2 there. And there you go. So how did we get the modulo? 19 divided by 5 is 3 with a remainder 4. So how do we get to that 4? We start with the 3 that we get from basic division. Then we multiply the quotient by the divisor. So we multiply that 3 by the 5 so we can see how many times 5 goes into 19 without exceeding it. And then we take that product and then we subtract it from 19 to get 4, which is indeed the remainder. So that's the algorithm behind getting the modulo. So now we're going to get into a slightly more advanced topic, which is functions. So what exactly is a function and how do we call them? So I'm sure most of you are coming from a background from a high-level programming language, and you guys should know that a function is just a set of code that accomplishes a particular task, however big or small. So for our purposes, we're going to stick with the modulo operation, since this is the first operation where we used multiple lines of code. And we're going to use that to write a mod function. Well, we technically already have it written. So what we're going to do is we're going to go to File and New File, and we're going to call it mod.s. And then we're going to copy these lines of code and then paste it. Actually, before we do that, hold on, undo. We need to first copy all the standard stuff here. And then we need to rename all the times we said main, to mod. Once we have that, then we can copy and paste. So let's go ahead and do that. Actually, we don't need that part. We can just copy this part. Alright. And then, so we got that. And we don't even need to set any specific value for the values we want to take the mod of, because this is just a function, and we're going to call this function in main. By the way, when you use the GCC compiler, main.s is the first file that it points to, or the first function that the compiler would read. So we have that, and the thing about having a function is that whatever value you want to return, you have to make sure that the return value is stored in register 0. That's one of the rules when using the ARM architecture for your assembly code. So for that, we just have to do a simple thing. We just need to move into register 0 the modulo result that we already have, which is R2, which is in R2. So we're just to be clear, we're going to write a comment saying store the modulo into R0 to be returned. And now that we have our function written, we're ready to call it in main.s. So we can delete that here. And since we're calling it in main, we actually need specific values here in main, and that's why I didn't delete this part. So we're going to stick with 19 and 5. And then to call the function, all we need to do is we need to make sure that our arguments are in registers 0 and registers 1. So the thing about the ARM convention is that registers, when you're using parameters, it needs to be in order from register 0 to 3, and then registers 4 and onwards is a different story. For that, there's something called the stack, which is a different topic. So what we're going to do here is we already have our first two arguments. So the mod function needs to take two arguments, which is the dividend and the divisor. And conveniently, because we've been using just the first few registers this whole time, we already have those. So in register 0, we have our first argument, so the dividend, 19, and then in register 1, we have our second argument, which is the divisor, 5. Now, to call the function, all we have to do is write BL, and then the name of the function, which is mod. And that's it.